3.4 Present value of an annuity and amortization. Let's consider this example. Suppose you want to receive payments of $10,000 annually for the next 7 years from an account that earns 6.35% compounded annually. How much money is required initially in this account for this to happen? So this leads to the following definition. The present value of an annuity is the amount of money needed now, so that if an investment at a certain interest rate for a certain time, equal periodic payments can be made without any money left over. Okay, so in this example, you can think of this one as like, hey, you retire and you still need some kind of source of income. So at the date of retirement, you're going to have so much money in your account, which we call the PV. Now, you're going to be able to pay yourself some money because even though you're not working, you still got to bring in some kind of money. Okay, so when you retire, what's the present value amount that you need in an account for you to still pay yourself? Alright, and again, let's pay careful attention to this note when reading our problems. So for a present value problem, the account is decreasing in value to 0. Right, so when you retire, you're going to pay yourself $10,000 from an account each year, so eventually that account, that money, is going to head to 0. Okay, so here's our theorem for present value ordinary annuity, and it looks familiar, similar to our FV, or future value. Same variables, I won't talk about those, but let me just write this note. This formula will be given on exam. And everything else is the same. The only thing that's different would be the PV. This is the present value. So how much money do you need in the account for you to pay yourself so much money as time goes on? Okay, let's look at our first example. What is the present value of an annuity? So when you see that, I can't be any more obvious of what kind of problem this is. When it says what is the present value of an annuity, right away you know you have a PV problem. Okay. So first step, as always, write out your formula. PV equals PMT, and that's going to be 1 minus 1 plus R over M raised to the negative MT. And that will be all over R over M. Okay, so what is the present value of this annuity? That's what we're looking for. So let's write out our variables to the left. PV is question mark. How much are we going to be paying ourselves? $200 per month. So our payment will be $200. This is going to happen over a course of 5 years. There's our keyword, compounded monthly, so our M will be 12. And at an interest rate of 6%, so decimal form 0.06. Alright, plugging in our variables. Let's see what this reduces to. So we're going to have 1 minus 1 plus 0.06 over 12 raised to the negative 12 times 5 all over. And again, follow the orders of operation. Even though this looks nasty, work with the most inner set of parentheses. So there's that set of parentheses, but there's one that's even further inside. So let's reduce those. So we're going to rewrite 200, we're not going to touch. I'm going to have 1 minus, and we're going to punch into our calculator 1 plus 0.06 divided by 12, and that's going to reduce to 1.005. So the part we're reducing is right here. And that exponent will be negative 60 power. And that will be all over. And in fact, we can actually reduce the denominator 0.06 divided by 12. That will be 0.005. Alright, now let's reduce this numerator. So we're going to focus in on the numerator. And what I recommend is let's figure out what that 1.005 raised to the negative 60 power is. So the way I'm going to write this will be 201 minus, and when we're punching this into our calculator, you're going to type in 1.005, and then you're going to hit the exponent. So you should be typing in 1.005, and then the exponent, and then now at the very bottom right part of your calculator, to the left of the enter button, you're going to look for this little negative symbol button. So that is different from your subtraction. Don't hit the subtraction, the one again above the plus sign. You're going to want to hit this little negative at the bottom right and then type in 60. Alright, so that should reduce to 0.74137 21962, and that will be all over 0.005. Alright, so simplifying that numerator, you should get 200 times 0.25862788038 all over 0.005. And then when I do this quotient multiplied by 20 or 200, that should turn out to be $10,345.11. Alright, so as always, we write our nice sentence for this word problem. So we'll say, in order to receive $200 payments per month for 5 years, the PV, the present value of the annuity, must be $10,345.11. Okay, so again, think of this as some kind of like retirement. Okay, over a course of 5 years, you're going to be able to pay yourself $200 per month, provided that you saved up that amount of money in this particular account. Okay, so moving on to this next example, let's look for those keywords that don't make it obvious that this is a present value problem, right? In the previous example, we had it super obvious. It actually said that word present value, but that's not always the case. So we'll look for these keywords that make this problem a present value problem. American General offers a 7-year ordinary annuity with a guaranteed rate of 6.35% compounded annually. How much should you pay for one of these annuities if you want to receive payments of $10,000 annually over 7 years? Okay, well, we see the word annuity, but we don't know if it's a future or present. But after reading this part, If you want to receive payments of $10,000 annually, okay, so you're going to be paying yourself $10,000 each year from an account. Okay, even though you're receiving this money, remember the account, if the account is decreasing to 0, we said in that note that this tells us that this is a PV problem. Okay, once you know it's a PV problem, write out that formula. PV equals T, and that would be 1 minus 1 plus R over M raised to the negative MT all over R over M. Alright, now we're going to go back and grab the correct variables. Let's start with the easy one, R. We see our percent symbol, 6.35%, which will reduce to, or become a decimal of. We want to pay ourselves over a course of 7 years. Payments, well, the payments are going to be 10,000, and we see that keyword compounded annually, so our number of compounding periods per year is just 1, right? 1 year in a year. And PV we don't know, that's what we're solving for, because it's asking us how much should you pay for one of these annuities. How much should you have in your accounts when you want to start paying yourself 10,000? Okay, so plugging in our values, so we have PV equals, it's going to be 10,000, 1 minus 1 plus 0.0635 over 1, and that's going to be raised to the 1 times 7 all over 1. Alright, let's simplify the most inner parentheses as always. And that's going to become 1 minus 0.649886 5371. That will be all over 35. Alright, I'm going to do the subtraction. Once I do the subtraction, I'm going to divide it right away, and that is actually going to give us this. So this whole fraction in here will give us 5.51 35,978,41, and that's going to give us $55,135.98. Okay, so this says, let's write our sentence. We must pay $55,135.98 in order to receive $10,000 per year for 7 years.